All right, everybody, welcome to the video here on polynomial identities. I know this was kind of a tough topic, but if you just kind of stick with the algebra, it's not really that bad. So taking a look at the first question here, so it gives us a binomial squared minus another binomial squared is equal to 4xy. And it wants us to prove that it is equal. So this is asking us to prove the identity. So the first thing I want to do is I want to square everything. We want to kind of follow our rules of PEMDAS here. Right, those of you that maybe tried to distribute or something like that, it's too early to do that. We got to get rid of the exponents first. So if I make some boxes here, let's see, what color should we use? Blue. All right, so if we make some boxes here, so we have x plus y and x plus y. So we have x squared, xy, and y squared. So we have x squared plus 2xy's plus a y squared minus. Now, this is exactly the same as this, just minus. Now, if you think, what's going to change? The first term is going to stay the same, but instead of these being pluses, they're going to both be minuses. So you're going to get a negative 2xy. And here, you're still going to get a positive, right? That's a y that's negative. So we wind up getting y squared. If you don't understand what I just did there, do the boxes again. It's okay. All right, but if you start seeing the same structure over and over and over again, don't drive yourself crazy. So now we want to see if this all equals out 4xy. Right now it doesn't look like it's going to, but if I do some distributing, right, distribute the negative, right? So if I distribute the negative, the x squareds cancel, the y squareds cancel, and I'm left with 2xy plus 2xy, which is 4xy. Proven. All right, let's try another one here. So we want to try and show that this is an identity. So anything cubed is going to be that term times itself 3 times. So we want to do the first two first. So I want to take m and n and multiply it by m plus n. So I'm going to have m squared, mn, mn, n squared. So we wind up having m squared plus 2mn plus n squared times m plus n, and I want to see that it's equal to m cubed plus 3m squared n plus 3mn squared plus n cubed. So we have one more tabular method to do here. So we got to multiply that whole piece out. Let me find some space here that's going to work for us. So we can do some tabular here. Give yourself some space because of all those variables, right? M squared, 2mn, and n squared. We have m and n. So we have m to the third power. Good. We have m squared n. Remember, alphabetical. Make sure that you always get good like terms. So 2mn times m. The m's are going to multiply. So I'm going to have 2m squared n. These two things add up to be 3m squared n's, which is what we want. So we have mn squared in that box. We have 2mn squared in this box. Notice the n's are going to multiply. That also adds up to 3. But that time that's mn squared, which is what we want. And the last box is n cubed. Look at that, it works. So we would just say that this checks off. It is good. Number 3, the identity x squared plus y squared squared is equal to x squared minus y squared squared plus 2xy squared can be used to generate Pythagorean triples. Show that this statement is an identity. So we want to show that both sides of this equation are the same. So if we rewrite this, right, do some tabular stuff here. So I have x squared, y squared, x squared, y squared. So I have x to the fourth, x squared, y squared, x squared, y squared. Remember, alphabetical there is best. And y to the fourth. So the left-hand side here is going to be x to the fourth plus 2x squared, y squared plus y to the fourth. We're just doing algebra. That's all we're doing here. Now, nice thing, if you notice the pattern here, these two things look exactly the same, but one's a plus, one's a minus. So that's going to become x to the fourth minus 2x squared, y squared plus y to the fourth. If you don't see that same structure, that same pattern, use your boxes, plus 4x squared y squared, right? When you square something that's a big product here, you just square all the pieces inside. Combined up your like terms here and here, and we wind up getting x to the fourth plus 2x squared y squared plus y to the fourth. So it checks. The last part says pick values for x and y where x is greater than y to generate a Pythagorean triple. So if I make x 6 and y 5, this should make a Pythagorean triple. So if I do x squared plus y squared squared, so if I do 6 squared plus 5 squared squared, that should be equal to 6 squared minus 5 squared squared plus 2 times 6 times 5 squared. So using my calculator here, this should make a Pythagorean triple. So if I do 6 squared plus 5 squared squared, that gives me 3,721. If I do the same thing but minus, that's going to give me 121. And if I do 2 times 6 times 5 squared, that's going to give me 3,600. So we wind up getting a Pythagorean triple here, right? These three numbers work in the Pythagorean triple. Also, we're going to get some perfect squares. So my triple is actually going to be 11, 60, and whatever the square root of 3721 is, 61. That's your triple. Where did those numbers come from? This is something squared. This is something squared is equal to something squared, like the Pythagorean theorem, right? So we want to see what are the numbers that are being squared to make those three values. There you go. Hopefully this video helped. Just so you know, right around lesson 8 or so is where we'll probably have a quiz here, just looking towards the future, right? If you need to look back at the other videos to get help and such, that'll go a long way for you watching them. All right, best of luck. Have a great weekend if it is a Friday. Bye.